Hello, hello. Cats, 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 cats. I don't know why it's not adjusting. Oop. Hi, everyone. This camera doesn't want to show white cats. That's a great start to the video. The camera is not very good, is it? White cat balance, yep. The white cat balance is off. Hi folks, we're just getting started here. I was running a little hot getting everything set up. Didn't go for a run until an hour and a half ago, and then I had lunch and then I showered so I would look not like I just run. Hi David, hi Juan, hi Alvaro, hi Andres, hi Jeremy. Our ghost kitties. Thank you for the chat test on Twitch, David and Alvaro. Hi Benjamin. Oh, perfect, Benny. I should cover the TLS stuff first. She hates it when I'm talking. That's why I always have to. Vin, do you want to go out? Yeah. I'll kick her out. Hi, Rod from Sydney. I'm gonna let the cat go out of the room. Okay, come on. Go hang out with Mom. Or say hi. All right, sorry about that. Bruce S is in the chat. Johnny's in the chat. Scoot34 is in the chat. Hi, everyone. Hopefully we're going to have an exciting time here. Whew. Cat cam is not looking good today. I've been, I swapped. I have two computers under my desk. I have the one that, like, backs up all the files on, and then I have the one that I use for all my development now. Hey, Catcom heard me. And I swapped where they were because, like, I use the left side of my desk here a lot, and use that for, like, Saliers and stuff. So that's actually where I need all my USBs. So I swapped where they were. I unplugged all my USBs and plugged them back in. And I've been having a heck of a time getting my camera reliable. So let me know if this video pauses. Hopefully it won't. I picked the USB port that's labeled 10 gigabits per second, which hopefully is enough. It's the only thing on that USB port. I've been doing a lot of research around a lot of research around like internal motherboard structures for modern desktop processors, wanting just like the most reliable USB bandwidth. So if you have any tips about good motherboards for USB dealing with like multiple HD video streams, let me know. I'm probably gonna do that at some point. Johnny says, I'm playing around in CircuitPython with my mag tag and some sensors. That's exciting. Hi, Mark. Yeah, did you hear the cat? She's not too happy. Okay, we're already 5 minutes in. I guess I started a couple minutes late. Yeah, Alvaro says, I hear this is the place to win Bitcoins. We've been having a lot of DM spammers on Discord right now. So if you want to participate in Discord, you can go to adafru.it/Discord. We have been actively banning people who are DMing. DMs are really hard to moderate because they're not like part of the server. The only reason that we have any influence over it is that like the de facto or default setting for like who can DM you is like if you share a server with them. So like even though the conversation is not actually happening on our server, if somebody shows us that like, hey, this happened from these people, then we've been banning. And it's weird because we're not in server discovery, so I'm not exactly sure like how the spammers are finding the server in the first place. But shout out to all the mods who've been helping people who've been reporting it. So if you do see that, let us know. We'll take care of it. Yeah. Alvaro says, I got one from Helium's Discord, but none from here. Yeah, I actually just got one. I just got one myself like an hour or two ago. When you get a DM that's spam, what you can do is you could click the user and select profile and then see your shared servers. So you can kind of see like what server are you in that is like allowing people to do that. Mark Olson asks, is the auto reload on save a CircuitPython only feature? Yes. Yeah, and that's a distinction I tried to draw. Like the fact that it shows up as a drive is not actually a CircuitPython specific feature. It's a something we inherited from MicroPython. The thing that I changed was the auto reload on save. Okay, so I talked about Discord a little bit. Let me pull up my notes. I sent in the Discord the link to the note stock. I should say, since I'm talking about the note stock, I do try to put in the YouTube description the time codes so that you can like see throughout the video. Last week's didn't look like it worked, and I'm not sure why. So if anybody has some insights on that, let me know. And I also wanted to just say an early thanks to David G, who's in the chat. Made this timer code for Clue. I meant to use it today, but I was, like I said, I was kind of like running out of time to get everything set up. So I wasn't actually able to set it up for today, but it's on my to-do list, and I will hope to get one set up so I can use it in the future. What David made was like a CircuitPython sketch where it keeps track of the time on the Clue, and you just press a button and it types in the time code for you. Which sounds super handy. So maybe I'll try to do that for the Monday meeting. Although I'm not the one running it. But yeah, so premature thanks, early thanks for David on that. So if you don't know who I am, my name is Scott, and I work on CircuitPython for Adafruit. CircuitPython is an open source version of Python. So it's not based on desktop Python. It's based on MicroPython, but it's geared towards beginners, people who are just learning to code. And they're learning to code on small devices called microcontrollers. Adafruit is an open source software and hardware company who develops small pieces of electronics that allow you to use sensors and things like that to interact with the real world from code that's running on an inexpensive computer called a microcontroller that usually just looks like a little chip. So they pay me and a number of other folks to develop CircuitPython, which is the software side of how do you make things with microcontrollers. If you want to support them, you want to support me, you can go to adafruit.com, purchase something there. Last week was pretty exciting because I was talking about a top secret product, which is the, let's see. So I was talking about the top secret version of this, which is the mag tag people are talking about. And it was actually put in the store during the stream, which is exciting. So here I have the first run of the mag tag, which is pretty exciting. So that's how I get paid, and that's how Adafruit is paid as a company, is that we sell little widgets like this. So you want to help me, help them, and you can help me by helping them, and they pay me to work on CircuitPython. So this is a deep dive where I take questions and talk about CircuitPython internals. So I'm always open to questions. I always have like some things in mind that I want to talk about. If you want to get a preview of what those are or add things to the list, the note stock I share, people can edit it in the Discord. And I'll go over that a little bit in just a bit. But first, I wanted to say, yeah, so this is Deep Dive. I answer questions, and I usually have like a technical topic that I want to go over. Usually it's on Fridays at 2 p.m. Pacific, which is like 11 minutes ago. I'm in Seattle. That's why it's Pacific time zone. But occasionally it's next occasionally when I want to take Friday off or do something else on Friday, I'll shift it to Thursday. And I just want to say next week is on Thursday. So next week is 24 hours earlier than it normally is. We're going out of town for the weekend and going to have a nice long weekend. So that's going to be nice. Last up, just a heads up that the cat in the camera who's still in here, who I didn't kick out, is epileptic, which means he has seizures. He has them rarely. It's actually improved a lot recently. But if that happens, I'll just take my headphones off and make sure he's okay and then come back and continue on the stream. So that's that. Yeah, and DCD points out that there is a current, pull up my desktop, thing on Adafruit. If you set up two-factor authentication, they give you 20% off. Two-factor authentication is really something you should do whenever you can. It's like the little code thing that shows up on your phone. It's just another way to ensure that like the person who's putting in your password like also has access to your phone. It reduces and it's actually like pretty good for securing your accounts. So that's recommended, and you get 20% off, which is exciting too. Okay, so that's housekeeping. I'll take a time code and just go over the plan. So it's been kind of a smattering of a week for me. Hello, Nettie. And a hi, Unexpected Maker. Hi, Tyler from Periscope. And Toddbot's in the Discord. Mark's in the Discord. Mark Gambler is in the Discord. And Keith EEs says the mods have been awesome in response to the spam on Discord, so that's good. Alvaro points out that actually my two-factor device is not a phone, it's a Pi portal. So note that. You could do that as well. Bad Abby's rooting for web server support for the ESP32S2, which is not high on my list, honestly. But I know you're rooting for it. Hi, Charles. Charles says hello to everybody watching. So it's been a smattering of a week for me, and I would just kind of want to go over what I've been doing. And I think I actually have a pending PR that I actually need to follow up on. So that's part of my plan. It's been a lot of work centered around the MagTag, which is the device I showed earlier. It more went in the store on Monday, but I think it's sold out again. So just sign up for that and keep an idea on it. Dylan asks, is the two-factor authentication on PyPortal an Adafruit only thing, or would that work with other accounts? It works with other accounts as well. I believe. The way that the two-factor thing works is it's basically like there's a secret key that is shared between the like website and you, and then you generate numbers that the other side can confirm that the number was correct as well. So that you just need to make sure that like the timekeeping is close enough between the two as well. And it's a standard. Yep. Yeah. So Alvaro says I have it for GitHub and several other places. So that could be really helpful. Okay, so yeah, I want to talk about two bugs for the ESP or for the MagTag. And then I want to talk about the TLS bug. And actually, maybe I'll do that first because I know Benny's in the chat. Hi, Tomas from Portugal. Hopefully I didn't butcher it too bad. Since Benny E is in the chats, hopefully he's there still. Let's talk about that first. Maybe we can find some folks who understand the TLS as well. Yeah. Thank you for the time code. You're a smidge ahead of me, but that's fine. It's like 14:18 right now. So you're about 20 seconds ahead of me, I think. And David linked to the PyPortal guide for two-factor auth, so you can check that out. There's a guide for it. Bruce S says I use Authy and 1Password. Yeah, I use Authy as well. Okay, so there's this issue here. Let me make it a bit bigger. So most most, maybe. Sites work with HTTPS on the ESP32S2. This is not one of them. Benjamin says, I'm here still, and Jeff created a patch for the IDF. Yes, I saw that go by. Could you Discord me the link and I'll pull it up? I'm not sure how to find it quickly. But yeah, so there's this issue where api.thingspeak.com was not working and io.adafruit.com was not working either. There's a big, long discussion here. And the reason I was excited Benny's in the chat is that Benny's been helping debug it, which is really helpful. So I took a look at it yesterday and noticed that one thing that Adafruit, IO, and ThingSpeak, they have the same root certificate issuer. So I'm not super knowledgeable about TLS, which is the way that... Thank you. So let's open this too. Thank you, Benny. So let's see what... I haven't even looked at this yet. Let's see what Jeff says. He says, this allows CircuitPython on the ESP32S2 to successfully connect to Adafruit IO and like standard browsers. This is if flags. Interesting. I don't know if that's the right. Interesting. So let me try to take a step back and explain it as well as I know. So here is Adafruit IO, and I'm in Firefox. What I can do is I can click, if I just hover over here, you can probably read it. It says verified by DigiCert Incorporated. And if you click here and then connection secure, you can actually get more information about it. And you can go so far as to view the certificate, which I had open in another window. So the way that this works is there's a handful of root certificates. These are the like top level entities that we have to trust, that the things that they hand out are trustworthy. I'm not a security person. If you are, I'm sorry in advance. And please correct me in the chat if I'm going off the wrong direction. But so what happens is that there's a handful, like 130 or so, of these root certificates. And what that allows you to do is, if you trust this, you can confirm that anything that derives from that is also trustworthy. And the way that you do it is like the certificate that says that we are Adafruit on the other end of this server is signed and verified by this intermediate GeoTrust people. And we can see here that they're it's also a DigiCert one, but it's called something different. And you can see when it's valid and cryptography information that I don't know much about. And then at the top level, this is the thing that you could say like, oh yeah, these are the things that I know and that I trust, and therefore I can trust anything that derives from it. What I noticed with the IO and the ThingSpeak thing is that the root certificate here is the same. And in particular, the signature algorithm here was SHA-1. And so what I found yesterday, and then Jeff also found, was that there's a setting in the IDF that says allow SHA-1 in these certificates. And once we allowed that, it seemed to work. Now the problem is that it SHA-1 is deliberately disabled. Let me find where it happens. Do I remember? Okay, so what I do have a branch of my own that is TLS debugging. So we can see the changes that I made yesterday. Just go into the commits, and I guess I should have just clicked it. So one thing I tried was switching us to the root certificates that Nina firmware does, which is something we still want to do, because at least like our Nina firmware is something that already does all of this encrypted HTTP stuff. And there were a couple like Amazon IoT root certificates that we wanted to trust as well. I found some things about debugging. So like if an ESP check fails, like I found a way to switch it so that it prints out more information about why it failed. So that's in here. Ben Harper says, I remember seeing some discussion about roots with SHA-1 hashes. The hash ends up being unimportant since they're trusted by nature of being in the store, not by the hash. Ah, that makes sense. And then David G sends this as well. So Digicert to stop issuing SHA-1 code signing certificates. So in under a month, they will stop issuing these sorts of certificates. The industry is moving away from SHA-1 code signing and SHA-1 EV code signing certificates. I'm surprised they don't just say straight out say because it's like been proven to be less secure. Basically what happened is people determined a way that they could reproduce the same SHA-1 signature with actual, like the contents being different, which makes it insecure. So for the root it is okay. And Alvaro says, yeah, SHA-1's been out for 15 years or so. I think SHA-1 is also used by Git, right? And there's some concerns about that as well. Maybe it would be nice to improve Adafruit's SSL. Yeah. Collision is the word I'm looking for. Meaning you can get the same hash out of different data. What is this? Analyze. B rating. Yeah, that's because the server supports 1.0 and 1.1. Ben says, my bad, root is okay, intermediate is bad. For example, there is no anchor for the roots. Right. Right, but the signature, my understanding is that, maybe I don't understand it. So the root certificate, you trust simply because it was given to you. Like these are the certificates we trust. But the signature algorithm, I thought, was like how it signs the derived ones after it. But maybe I'm wrong. Anyway, this is the bug that we're still kind of like trying to wrap our hands around. Let's see, is there anything else interesting in here? So Jeff also ran into this issue where if you turn debugging on, these checks actually happen, and this net interface dinit doesn't actually work. Like there's no way for it to actually pass. But yeah, so there's not a whole lot in here. It was just a lot of Bruce S says, like my hair, weak roots. Yeah, so I mean, I was just starting to dig into like, we use this library called embed TLS, which is like one of the standard like microcontroller level. Yeah. Ben Harper says Subversion and Git repos can be broken if two files have the same SHA-1, which is extra problematic if they upload the proof of concept to a repo. Ben says that dinit was also the reason for my backtrace, I guess. Yes, if you're running debug mode, it will give you a backtrace. Yep. Yeah, the check fails and then it asserts and gives you a backtrace. So yeah, that's probably what you saw. Which is kind of silly. Like I looked at the implementation and it has two different ways for it to fail. There's no way for it to pass. But Jeff actually has a PR out for fixing this already. So it is yeah, David G says, so it's missing an option that does not disable SHA-1 for root, but refuse it for all other levels. Yeah, I suppose. I guess this doesn't show it because it's in the IDF. But if we go to Adafruit CircuitPython, we can find the version of the IDF that we're using. So ports ESP32S2, ESP IDF, and this kicks us over to the other repository. But it's in, let's see, components. So the top level component we use is this ESP TLS, and then it uses embed TLS underneath. And I think it's in port include embed TLS ESP config, maybe? SHA-1. I don't think this is the right file. Like, this is almost it, but that's not quite. Let me do a... Where did my console go? I have been having bad USB times today, so far so good. Ports ESP. I just restarted, so it wasn't a config H. You're right. The question is, what folder is that in? ESP config. No, I think Jeff also mentioned it in. There we go. This embed TLS default allow SHA-1 in certificates. Yeah, not the key exchange one. And it says, actually, no, that discussion's different, but it's in, it didn't tell us what file it's in. Why didn't it tell us what file it was in? Because there's only one result? I guess I can search for it explicitly. Man, it's like sunny out. It's like pretty bright. So it's in components, embed TLS include. So if we go back. Oh, okay, and then it's in a submodule there. That's true. Checking certificate also means you have a good clock and checking the validity. Once you said CircuitPython is not for security, so you could accept weak certificate to maximize the number of servers it can connect to. Of course, Adafruit IO is important. Yeah. Yeah, I mean, it's a trade-off between actually being secure and like just not giving up completely. So for example, like in the ESP IDF, they have the ability to like turn on TLS 1.0 and 1.1 support. And I wanted to just turn that off by default. Like I wanted to, if I have a config option where I can pick the better option, then I should do that. Like even if I make no promises about the quality of it, I should still not actively leave open holes. Right. David says, what would be interesting is clear instructions on how to add a trust authority, another root, so that I can put the company one in a CircuitPython gadget where I would recompile the firmware. So I do want you to be able to include root certificates of your own from Python land. So if you look at CPython's SSL, this is where I think the notion of a context comes into play. So like right now, the only thing we support in CircuitPython is this SSL create default context. But what you can do is you don't have to do that. You can actually like create your own context with a bundle of roots of your own. So I think that's the way to do it. Is like, yeah, we could show you how to add roots into a build yourself, but I think you could also just do it this way of loading them from Python land, which is probably not as secure for some reason, but I don't know. Alvaro says, well, CircuitPython has been and will be in space, so making it insecure is not a good idea as well. Yeah. So yeah, Benjamin says, I think it would be good to give an option via the default context option to make verify optional. So this is, I was just thinking about this. I know you said that in the issue, and I think my answer would be, it's however this would make it optional, right? So this is the API that we're working towards. So let's just take a look at this. Like, purpose, server auth, CA file, CA path, CA data. If all three are none. Right, I know what you mean. Like if I try to log into my my like router here, it's signed with a self-signed certificate, and this would fail. So the question really is just like, I'm totally fine having a way where you can skirt it, but the question is like, how do you do that in CPython? Like, how do you, yeah. Verify code. Certificate handling. Like, I assume CPython has a way to do that as well. It's different via URL lib 3. Making disabling everything the easiest way to get around things not working as intended makes it more likely that people just disable it all the time, even when not required. Benny says that's it. At least that's where you silence the exceptions in URL lib 3. Yeah. Yeah, I mean, I wonder if oh, here you go. Possible value for verify mode. Or the cert requirements parameter to wrap socket. With client-side sockets, just about any cert is accepted. Validation errors such as untrusted or expired certs are ignored and do not abort the TLS or SSL handshake. In server mode, no certificate is requested from the client, so the client does not send anything. Right, so this looks like what like verify flags is the things that you would want to change. The verify flags. Interesting. Yeah, I mean, I'm just learning all of this stuff. So you can do SSL create default context verify mode. But it looks like it's read write. Ah, yeah, for URL lib 3, you just disable a warning. Interesting. Yeah, David's pointing out the fact that like how to trust self-signed certificates. But I mean, if you're creating your own self-signed certificates, you just add it as a root. Right. So in Python, we always get the error for such a self-signed certificate. You can fix the same by passing the certificate in. Anyway, so that's the question is like, why is it erroring? Well, there's a number of questions that I don't fully understand. But the question in my mind still is like, what is the best fix? And I think David's kind of getting at the crux of it is like, if the root certificate that you have in your bundle of things that you trust is SHA-1, then like you already kind of support it. Simon says, "Hi Scott, the thing is a number of websites are dropping TLS 1.0 and 1.1, so the use is very limited now, as 1.2 is the widest version supported by servers and clients, also with 1.3. Yeah, good. So it looks like the IDF supports 1.2. I didn't see any 1.3 support. So we're like, I wanted to hopefully reduce the amount of code that we have in the IDF or in the ESP generally. Which is why I turned off 1.0 and 1.1. Yeah, 1.3 is being adopted now. Yeah, I noticed that. You could see it here or earlier on, and to like tell me about how secure this is. More information. Yeah, so here we can see connection is encrypted with TLS AES 256 and SHA 384 with 256-bit keys and TLS 1.3. So like this is something browsers have already thought about it. Ben says certificate pinning can also be useful, but less likely to be in the threat model for CircuitPython. Yeah. I don't know. I don't actually know what certificate pinning is, but yeah. So security is all about threat models, in my understanding, and I've never really been in a position to do a lot of security work, but the gist of threat modeling is that, like, in my opinion, nothing is perfectly secure, right? And so the threat model is the like analyzing the context for where security matters and like understanding like how hard you want to make it to break, and match like the things that you're most concerned about. That's my understanding. All right, any other SSL TLS stuff? Jeff has a fix. So this, right. So Jeff's change says, basically ignore the errors if it's in the cert bundle itself. Which I guess makes sense, right? It's what David was talking about. It's like, it's the root because it's in your bundle. So ignore that ignore that bit. And yeah, and I think Jeff and I were talking about this earlier. That's part of the reason I was a little late. That the Nina firmware doesn't use this like weird certificate verify callback that is unique to the ESP TLS component. So yeah, if you are a TLS person and you understand this, like Benny, for example, please help us out. Let us know what is weird and what needs improving. We're looking to make things better over time. I will never ever promise that CircuitPython is secure, but we should not try to be insecure, if that makes any sense. Okay. I don't see any other comments. So let's keep going. So that was one of the major things. Let's talk about the Grayscale 41. So the stuff that I worked on in the start of the week is I think still in a pending PR, so let me pull that up. Yeah, Mr. certainly says, might not be Fort Knox, but at least you're getting the low-hanging fruit. Yeah, and that's kind of threat modeling, right? Like, we don't want it to be egregious, but we also don't want, like, the higher security levels you want to achieve, the, like, exponential more time you're going to do it. David G says, you have 3 network stacks, Nina, ESP32S2, and the WizNet 5000 Ethernet module. What else? There's 2. I had a meeting with Brent, and he's started work on the MiniMqTT, updating it to use like real sockets. And he pointed out that in the examples, it also has Ethernet and cellular. So cellular is another one that we have to think about. And so like this first generation of like CircuitPython networking libraries kind of like grew out of the ESP32 SPI work, and like a lot of the weird idiosyncrasies of that work propagated to the WizNet stack and the cell stack as well. Brent was part of that, so he should be able to find it and help fix it too. But yeah, cellular is the other one. Okay, so let's look at pull requests. So I have this, and I actually need to fix it. So that's one thing I can do. I had one failing check, which is like, oh, so frustrating. So there was 2 issues. And actually, let me show this with... Did I show this already? Did I show it last week where Arduino's grays were different than CircuitPython's grays? I don't remember if I did. But this is an old example, and maybe I could pull up the new example of this. But like all the grays are pretty dark. The lightest gray is still okay. Unexpected Maker says yes. So yeah. And a few weeks ago as well. Well, we figured it out. Okay. So what I asked Lamore to do is give me a copy of the Arduino code, and then I ran it on a Salier logic analyzer, and I just like went command for command and took a look at it. So if we see pull request 14 is where I fixed it. And it was basically this VCM DC value. There was another thing I figured out was that it had been a while that so these start sequences are these weird things. They're these weird blobs of bytes. And the way that it works, the reason it's a weird blob of bytes is I want to like reduce the memory overhead of having it as much as I can. So it's like one format ish that the Arduino code already has. So it was like kind of like inheriting that as well. But it's the command number is the first thing. The second thing is the number of parameters. So here you can see it's 5 here, and there's 1, 2, 3, 4, 5. Hold on, I'll make it bigger. Not smaller, bigger. So the way the sequence works is that it's the command, so that gets sent on the wire with the command line correct. There's usually like a command data line to go along with it. And then the second number is the number of parameters. So these 5 get sent as well. But there's this also thing that is encoded where you have the option of delaying after you run a command. So if you're like starting things up and you need to wait for it to stabilize, these command sequences have that as well. So here's an example of like it sends command 4, but the highest bit in the command count or the parameter count, the 8, says O and delay, and the C8 is 200 in hex, I think. So that says wait for 200 milliseconds. What I got wrong is that the documentation for these command sequences said if you have an 8, the next thing after it is the count. But if I looked in the implementation, and that wasn't actually true. The way that it actually worked in the implementation was that if there's an 8, the last value would be the delay. So that means that this 32 was being sent when Arduino was actually sending 12. 32 is 50 in hex. So what I had to realize is that this one parameter here was incorrect. And that's the VCM DC. Let me see if I can pull up the data sheet. I think it starts with a U. Is that what it was? Yeah. This data sheet here. And you can see I already have it on the VCM DC setting. And you can see it's a voltage. So basically it's like a reference voltage when it does the sequence to like move the ink blobs and the e-ink around. So basically by raising it from, or lowering it from 32 to 12 hex, I changed the value. And that meant that it was like not as strong, which meant the gray was lighter. So that was one issue. So we now match Arduino in the gray. And thanks, Keith. Keith says, wow, that's a testy bug. Nice job narrowing it down and finding it. Yeah, that's one reason I really like logic analyzers, is that it like gets you away from the I think this is what the code is doing to the like here's the bits that are on the wire. And like when I compared like the Arduino code and the CircuitPython code, but like if your mental model of like how that like send sequence doesn't work out right, like maybe that's not true. Yeah, so David G asks, is there a macro processing that could help put readable firmware message, but does that have a cost at runtime? So because this is a Python file, there's like no such thing as, like we could auto-generate the Python file, but like Python itself has no macro sorts of stuff, which is unfortunate. And one thing I was considering in terms of like what my first contribution to CPython could be is actually like better literal formats for byte arrays or byte strings. But yeah, so the lesson I think from here is like really like if something's weird and it's not working like you expect it, like ground yourself in the reality of like what is actually showing on like a logic analyzer, I think is a really good approach. And which is one reason I would love to get back to doing the tiny logic friend stuff. Yeah. So Tomas says, so changing that value would be like adjusting the contrast level of the display. That could actually be nice to tweak for some images that are too light. Yes, Yes, and this I think is something that this is something that could be very, very interesting. And Lamore looked into this more than I did, but like there's actually a lot of people that have experimented. So the way that the displays work is that they do this sequence of voltage changes that like Colin has a great video. Let's see if he did like some nice motion graphics. But it's only a minute long, so let's see if I can't just find it. Which one is it? This one?
Chrome counterparts, but they need a lot more time to refresh because of that one extra pigment, which is usually red.
Is that too loud?
And that pattern on the surface may look like separate pixels, but it's actually separate groups of pigments. The display's internal layer is divided into compartments, each containing negatively charged white, positively charged black, and positively charged red pigment of a larger particle size. Just like a monochrome EPD, black and white pigments are
Volume's fine. Thank you, Dylan.
displayed by applying charges to the top and bottom electrode layers. To display red, the EPD first displays the black pigment with the larger, slow-moving red particles below. Then a charge of the opposite polarity is applied just long enough to pull the black pigment downward, but leaving red in the top visible position.
Right, so kind of my mental model is that with the grayscale e-ink, it's not actually that there's 4 different bubbles of gray or like color. What it is that it's two, just the white and the black still, but what I was imagining is that the granularity of like the charge or the size of the particles is like broader, which would mean that like you have that like in the same way that the red is slow to react, is like some black might be slow to react whilst and vice versa, which means that it's like more sensitive to like the timing differences that can happen. And so there's a couple ways you can achieve that, right? There's the like what Tomas was talking about is like the stronger this like VCM DC is leads to contrast. But what you can also play around with is like simply how long those like patterns are playing out. So like if we look in like further down here, we have this grayscale start sequence, and there's this big long there's this big long list of what looks like nothing, but what it is it's like a sequence of things. So David G asks, but then why only 2 shades of gray? So I think the answer with that is that you can only have so many sequences of these like different timings of voltages. So here you can see there's a white to white, a black to white, a black to white, white to black, and black to black. So like those are 4 options, which means we have 4 different like sequences of voltages and timings that we can do. And so this grayscale is really a hack. So there's 2 bits of memory, and it has the ability of like doing this like differential refresh. So theoretically, you could have just like white to white and black to black, just do not do anything. I think. But instead, what you're doing is you can actually fill out like these two things of memory. Say, like, this is the one we want, and this is the old one. And based on what the old one is and the new value is, like, pick one of these 4 sequences. But if you want grayscale, what you can do is you can say, like, here's one bit of the 2 bits I want, and here's the other bit of the 2 bits I want, and then those 2 combine to like pick one of the 4 sequences. So I think that's it. So the point is, and what Tomas is getting at, is that like there's a lot of experimentation that can happen with these displays. So if you want to play around with what the grays are, and I think what you can do is also like David says, why only 2 shades of gray? I think you can actually do more. What you'll just end up doing is you'll like load new, like more bits of data and have them like make finer tweaks, so to speak. There's a really good, I think it's like a Hackaday talk that I watched about like everything I know about e-inks. It's really good though. If this is interesting to you, that's a really good resource. And then Doc Malo points out there's fancy 7 color ones, which I am not that looking forward to supporting, honestly. It's kind of the weeds of like display AO, making it work okay. But there's this new panel on the market that is 7 different colors. Yeah. Yeah, Doc Malo linked to it too. Right, so Keith E says, I might be completely missing something, but if the Arduino and CircuitPython got different grays and these cycles are kind of different, can you get more gray resolution out of the panel? I think yes, but it takes more work than the four steps of gray. Because you only have 4 different like voltage sequences that you can have it run automatically. Where is that Hackaday e-ink talk? I think it was last year, like SuperCon. Maybe somebody can link me to it. But yeah, there's a really good resource. It might be called e-paper. No. I don't remember what it's called. If somebody could find it, that'd be awesome. But it is really helpful. And they talk about... Hold on, let me ban somebody. Block. Right, Tomas says, I guess if you play around with the ghosting effect that e-inks have, it could be possible to get more grays. Was it Ben Krasno's stuff? It might have been. I'm pretty sure it was a SuperCon talk last year. Yeah, this is more like trying to go for speed. I don't know. I'm sure Joey knows as well. Joey, who does open book. Jules work. David G says, can I shake the screen real hard and erase the image Etch-a-Sketch style? I don't think so. But one thing you'll notice with the red is that the red displays get... the red displays kind of like bleed red over time. So if you like leave it for a while... And I think the display datasheet even says like when you leave it for a while, like leave it face down or face up, that sort of thing, because there's actually like an influence to it. Hugo Dolls sending Vim commands. Hi, Lav Game. Would a magnet affect it too? I'm not sure. It is charge based, so perhaps. I haven't tried it though. Yeah, honestly, I was really hoping I would have like the MagTag project that I really want to do here, but Mr. Certainly says e-ink bleeding red. That's horrible, but great around Halloween. Yeah, I guess that's not quite right. It just like gets pinker over time. Is the better way to put it. To say it's dramatically red is not true. But yeah, I think this 7 color is on our radar as well. Hugo Doll says, dang it, that was supposed to be on my work remote desktop. For my next trick, watch me leak my username and password. Yep, you should be able to change your password, though. I was a little scared of this because this the weird one of the weird things about this Grayscale e-ink is that there's like 2 separate bit ranges. So even though it's like 2 bits, 1 bit is here and 1 bit is there. So you have to like display IO ends up doing 2 passes, one for like black or white, and then one for white or red or absence or red for the tricolor. But then I had to add another thing that said like, all right, I'm doing Grayscale and I'm doing this bit or that bit of Grayscale. So let me take a time code, or let's go to this Luma bug. And another thing I found as I was doing this was I spotted something that did not look right to me. So this PR, maybe a little big. Oh! I accidentally made it full screen. Gambler says, so far my e-ink with red isn't bleeding, but if it starts, I'll bandage it and get a picture. One thing I did is just the parallel bus send function wasn't taking a const array of ints, so a lot of the changes here are just adding const to things. Here you can see the version of the display init sequence that we saw in the other driver. So one thing I did in this PR that's still pending and I should fix is I natively initialized the display. So you can just do board.display on the mag tag once this is in. And so here you can see like basically the C equivalent of the Python code in the example. You create a SPI bus, you create a 4-wire display bus, and then you just pass everything into the ePaper display constructor. You don't have the benefit of all of the default values, which is kind of annoying, but it's not in the end that bad. It's kind of something you do once and then you're good. So here you can see that this is the pins.c maps to the board module you import. So this adds that display thing there. Another const, another const, another const, another const. I added this busy flag. So one thing Lemore and I think Lemore thought of was that we actually need to know like how long the display is busy updating, because we don't want to shut everything down until it's updated. So we have a busy flag. Turns out we already track this internally, so it just exposes it. And I like the name busy because when you construct the object, you have a busy pin. So, and that's what's used for this. If you have a busy pin, if you don't have a busy pin, you tell it like the maximum time that the sequence takes to update, and then it'll just track it for you. So I added that. More const here, const there, and here. So this is the bug that I wanted to talk about. I was trying to figure out why the grays were wrong, right? And one thing I didn't rule out was that this is actually, I found this bug because of John Park. So I fixed the grays, but then he did this, and I don't have it showing anymore, do I? He did this great bitmap. Let me find it. I'll show the original. Yeah. So John, everything needs me to log in again. Come on. Why is it asking for my GPG? Am I like starting Chrome up for some reason? Yes. Just to view a BMP, it needed me to... That's so silly. Because Chrome is the best way to view a BMP file or a PNG file. And it's actually terrible because it has this black background. But John was playing around with it, and he was trying to figure out what grays it was, basically. And so he posted this picture of like, oh, this is weird. Like, this is the percentage points where it switches between the 4 grays. So the top is what the like old behavior of CircuitPython was. So let's see, the black edge is like right here. So it's like a lot of black, a middle, and then a lot of the light gray, and then just a little bit of white. And it's like, I was thinking, oh, like that's because of the Luma stuff that I think I showed last week, where like if you balance the colors, like all the colors don't equally influence things. But then I got to thinking more as I was like trying to like a little bit of mansplain or explain to John of like, oh, that's because like it makes black and white pictures look better. And then I had the second thought of like, wait, that doesn't make any sense because his image is all grayscale, which means that it shouldn't matter like the balance between the red, green, and blue components, because all those components are equal. So like the output Luma should also be that value, because you're weighting each individually, but they're all the same value and then dividing it. And so that was really weird to me. And so I went in here and then I saw, oh wait, there's a plus. And I was like, oh no, like how long has this code been in there and it's been incorrect since I added it? Basically where, you know, red was multiplied, green was multiplied, but blue was not. It was added. So what that would mean is that like if you're doing a conversion from an actual color photo down to grayscale, like the blues are going to be underweighted and not contribute like any sort of, the blue component won't contribute any brightness. So I was like printing out like, here's the input color, here's the resulting Luma. And then I spotted that plus and I was like, oh no. So I did that. And then I also noticed that like, it wasn't super, it like lagged a little bit, where it was like all the components hit 4.0, which is like a quarter of the range. But it still didn't do that. And so I realized what was happening is that the original version was doing 3 divisions, truncated divisions though. So basically like you lose the remainders like 3 times and then you add them all together. So what I realized is what you could do is you could do all the multiplication, add them together, and then just do 1 division. And that means that you'll like all of the remainders will add up first. And so you'll get a lot closer to the real answer. So that's a bug that's been in CircuitPython for I think a year. I looked it up. I think like last July is when I added this code. So if you have been using that the like magically like here's a color photo and show it on a grayscale thing, it should produce better results. And I also wanted to make it clear that like, well, for one, the plus problem, even if you provided it a grayscale image, it would not actually respect it, because you'd underweight the blue component, which just like I guess just changes the linearity of it. And then then furthermore, the like truncated division is kind of bad too. So yeah, I'm happy about that. I feel really good about fixing it. There's the cons. Here's the get busy stuff. And one thing that's different about e-inks is that like with displays, we get in this chunk of sequences to initialize it, but we don't use that ever again. Whereas e-inks do this start sequence every time you do a refresh. Because the assumption is that you like actually like shut down the e-ink chip between times that you update it. And so you have to do the start sequence all over again. And the stop sequence actually shuts it down into low mode. or at least it should. So yeah, that's the pending PR. It's 3:15. Folks have any other topics? That's a nice segue to here. I know Bad Abby would like me to do the server support. So I could point out what... So I think for server support, what you need is bind and accept. So CPython socket, low-level networking interface. Interesting, there's a module that classes that simplify writing network servers. Like that's something we might want to mimic in CircuitPython or re-implement. I think, where was... I think there's also a how-to. Socket programming how-to. So there's bind and listen. And there's also accept. So basically like bind, listen, and accept are the things that we would have to add to CircuitPythons. So if you go into GitHub, Adafruit CircuitPython, there's ports, ESP32S2, Common HAL, socket pool, socket. You'll actually see that, oh no, I didn't comment it out here. So this is where you would put the implementation for those things. And then I think that in shared bindings, I left it in there. So if you do shared bindings, socket pool, socket. Yeah, you can see that like there's the original bind stuff here, the original listen stuff, and accept. So if you want server support, this is what you have to implement. It's not super high on my list. You know, my list is very much dictated by this device right now, because it's super cool. And the other main thing for it, well, besides getting reliable client internet stuff, is that low power is still on the docket. So I've handed that off to Dan. Dan's taking that work over. And I haven't heard from him, which means I'm hoping that he's kind of heads down on it. Oh, David points out that here's a tricolor e-ink that has been sitting in the drawer for 6 to 12 months. So white is now pink. Yeah, that's. I'll just drag that over. You can see how pink it is. That's like totally normal. And that's why, at least with the tricolors, it's actually like we recommend refreshing it once a day. Even if you want the same image, because it will like re-get everything where you expect it. So thanks, David. That's a good picture for that. Okay, so that's a detour into what it would take to do server stuff. It is not high on the list. What's higher on the list is just figuring out all these bugs and squashing them. Expect to see, I know Johnny likes to hear 6.0 updates. So we did, wow, I took a time code and then immediately stopped talking about what the time code was about. But there is now a 6.0 RC2. And we fully expect this to be 6.0 next week. The one reason that we did it as a release candidate 2 and not 6.0 was that it was already Thursday. and we get a lot more people trying the stable releases, and so we wanted to make sure that 6.0 was released early on in the week so that we would be around in case anything dramatic did happen. But expect to see a 6.0 out next week, and we'll probably do a 6.1 alpha or beta next week as well, just because there's lots of good stuff. And as I've said before, like folks using the ESP32S2 should continue to use the pre-release versions. So that'll be good. Okay, this looks really neat. I'm excited to, like, that's a big panel too. 5.7 inches. 66 pounds. That's not that bad, right? Like, that's like $100 or so. Mark says I now have two ESP32S2s, so I'm excited to play. All right. I'm excited to play around with this. I think this screen will likely take the same approach that we have for the tricolor. $87 USD. I think this will be kind of like the way the tricolor works, of like pick a set of colors with hues, and then Paul is almost caught up on 2x, and so I'll finally won't be a smurf. That's an interesting way to do it if you don't start at the start. You'll probably realize that once I'm at 1x that it's going to be really slow. David G says, put the ESP32S2 Pi 0 like board from Luma. Is that top secret? Oh yeah, use the top secret ESP32 on this board with the header for the Pi. Yeah, it's all good. I think that the challenge with something like this is like, I've gotten myself into this mess a bit with display I/O. I don't know the approach they're taking, but I did talk with Luma enough to know that like it's a 4-bit it's a 4-bit RAM, so like at least we can write all 4 bits next to each other. We just might have to say like, give me 7 highlight colors, and we'll pick like the value that matches each with each highlight color. Sorry, I'm slow-mo now. You could wait 45 minutes and then watch it in 20 minutes later. Let's just take a look at this PR, because I'd really like to get it checked in before the end of the week. But Juan Carlos has a question. Juan Carlos says, I have a question that's not e-ink related. My QT does not automatically reload whenever I save a file. How can one enable that for other boards? It should automatically reload when you ever save a file. I believe there was a bug. There was a bug on the SAMD21 where that was not true, and that was a bug. But if you do want to disable auto reload, you can call supervisor.disable auto reload, and then it won't do it for you. Juan Carlos liked the bug. Sorry. Yeah, it was a timekeeping issue. Yeah, I fixed it. It was a SAMD21 issue where, like, the way that, like, the ticks interacted with, like, if you're asleep, I think. Tomas says, my message did not show on the stream. It's... It is top chat, not full chat. Gareth asks, if you have 7 colors, do you need a lookup table for each possible transition? I'm not sure. I haven't played with it yet. We could probably try to find the display driver, but I'd rather not go down that dark path until I have a device to test with. So it's a good question. I don't know. I mean, maybe they have like intermediate states. Maybe you have like for every color you have a way to get out of it and back into it. I don't know. Mr. Certainly says, and I also have a question unrelated to anything discussed so far. Were stats collected from the voting site you created about how many people used it? So we did electioncal.us, and I think that, so funny thing, the thing that updates the website stopped working after election day. But I did like manually run the tweets out every day. But I don't think so. It was just we didn't have anything. We didn't have anything like JavaScript wise to keep track of things. Oh, this is interesting. That how the unique cloners drops to 0. This must be CI systems. Because the CI doesn't run anymore. I shut it off. But there's also unique visitors. Let's see, can we can't see traffic from a larger time period? No. There's a few from Mapbox. But yeah, no, unfortunately, we don't have that much. We don't have much data about how that did. There was good turnout in the US, though. Tomas says, any hopes of playing GIFs or slow frame rate videos on e-inks? I saw a video of an e-reader with e-ink that had a super fast refresh mode. I mean, unless you think slow is really slow. I think the problem is fundamentally that, like, to change the pixels, it takes, like, different amounts of time depending on what you're trying to do. And I imagine that if you want it to be refreshed really quickly, you don't get those, like, finer gradations of, like, color and stuff. There are things that you can do of like that transitionary sequencing, but then also there's the like you have the ability of like only doing the refresh cycles on a particular area of the screen, but that doesn't actually change your performance. Oh, I was in product mode the whole time. That doesn't really change your performance because like your lookup tables have a bunch of delays in them. So I don't think so. If you really like that style of screen and you want like video and stuff, the like sharp memory displays are the way to go instead. Like the ones that are on like here. I know you can't. I know there's nothing on it, but these sharp memory displays kind of have that same look, but they're like way more responsive. Yeah. Belgium has mandatory voting, so they get lots of turnout. I think we talked about this before. Okay, let's just take a look. So I just want to know, there's one failing check. And I think I found it. I wish GitHub would sort this by which one failed. So I don't have to go through this giant list. So the Metro Express failed. And it failed because we ran out of step. David says, need to step out. Remind Scott to do time codes. Thank you, David. We don't have too much more time. I thought it was that. I was trying to figure out why this was. So it failed because the German translation was 44 bytes too big. Oh, Tomas says the sharp memory displays look nice. Thanks. You're welcome. The cost of them just went down recently, which is why Lamore started carrying the larger one as well. It's actually like she wanted the one that's in here, but the cost went down, so that's good. Generally, display prices have been going down. Like the Ada box had the matrix in it, and like she found a new matrix supplier, and the cost went down for those too, which is cool. I don't really know why we're out of space on the Metro M0 like this. I changed something to const. I did some ESP specific things. I guess I added, oh, you know, this is what it could be. Like adding this busy thing might have pushed it over the edge. Ugh. Do I have any quick ways of getting some space back? Oh, and if you want to talk build systems, let me know. I might actually talk about that a bit, because my brain's been heavily in build system land. Okay, but I want to get this checked in. So let's just look at boards. There's a few knobs we can play around with easily. So let's just take a look at it. Like, we're pretty aggressive in turning things off. David says there's a German word for that. So we already have the GC turned off. We already have the VM optimization turned off and the C flags inline limit. So we've kind of thrown everything at the wall on this German translation already. So how can I get 44 more bytes back? This is so fun. One of the challenging pieces about this right now is that I'm actually, on my local box, I use a different version than what is the branch name? Magtag built-in display. So if I just make it here, it's possible it'll work because I'm using GCC 10, whereas the CI and the production builds are GCC 9. So if I make J13 Metro M0 Express translation DE_DE, we'll clean to make sure that we're starting from scratch and just run that. Hopefully it won't make my video hiccup. I'm actually trying to watch the CPU usage to see if it spikes while I build here. I've been looking at those new Ryzen CPUs, the 5000 series, and I am very tempted. If anybody has a motherboard that's an X570, which is a chipset for the AMD Ryzens, let me know, because I really would like to find something that is like has solid USB. Benny says, I just tried to build your TLS debugging branch, but ended up with something as being reported CircuitPython 5. And my driver is reported as a 12 megabyte drive. Yeah, if you manage to go through my master branch before getting to my TLS debugging branch, that might have. It's my master branch is really old, so it could have been that. Yeah, so here's Metro M0 Express German translation, and it says I have 1984 bytes free. How fun is that? Johnny says, how do you set the magtag background to white? What do you mean by that? What do you mean by background? Do you mean like in this, like the REPL mode? Or do you mean the outside? Like there's a kind of like a border area? Ah, Mr. Certainly says +1 for that request. I'm in the middle of building a sturdy performance PC, and flaky USB is something I won't tolerate either. Mr. Certainly, what OS are you using? Ben Harper says, is it already -OS everywhere? We don't do OS everywhere. We do it for the SAMDs. But we actually had a PR in the last few months, I think, where in the higher end parts where we actually have a lot of flash space, we actually do O2 because it's faster. But yeah, so with the SAMD stuff, especially the 21, we're -OS and we're LTO. So like we do full LTO on it. Oh, Johnny says set the full screen to white. You have to put like a white rectangle. You have to put a white rectangle behind it. You can't. So yeah, the default color for display AO is black. So if like no tile grid or pixel matches, like it ends up being black by default, and it's not configurable. And you say, oh, we should make it configurable. Well, this is the exact same problem you'll have if you add anything to the existing API, which is unfortunate. But yeah, Ben, it is definitely -OS. So, one, so 44 bytes is not a lot. Ah. Using a MacBook Pro 16 right now with Catalina, but I'm thinking of getting a performance Windows 10 machine with maybe a second bare metal Ubuntu box with the same higher quality components, but not as spec'd out. Yeah, so I kind of expect USB on Windows to be good. Like, Microsoft makes good stuff. Maybe I'm wrong because I don't use it, but I suspect that like it's a hybrid of Linux USB problems and like the implementations. Although so far so good. We've been going an hour and a half and I haven't frozen. I was video chatting with Jeff earlier and I froze like multiple times. But I was also like not I was not in the USB port that I'm in right now. Yeah, Benny says for the Ryzen 5000, the Asus ROG Crosshair 8 Dark Hero would be likely the best board. All of this is hard to get currently, though. Yeah, I know it's hard to get. I do. I'm on a first gen Ryzen right now. I can wait. It's not the end of the world. I've got another project I'm working on that'll make it better too. Just the build system stuff. David G says 44 bytes is the average size of a long German word. Maybe a couple German words, but still. And we do compression on the translations too. So what I think we could probably find. Ben says, figured there might be an off chance there was lots of debugging symbols. Yeah. Yeah, I mean, for the SAMD 21, we've been in this mode of like a couple years already that we've had to like really like find the problems, find the extra bytes. So one thing we can do is we can take a look at the firmware map. But really it's like firmware map is good if you need to figure out like thinking. Firmware map is good if you need to figure out that like you have something that's not being really used that's still being included. For example, we have some builds where we didn't have enough USB endpoints, so like USB MIDI's not enabled. But that would like it was still included and it didn't need to be. Actually, that does give me an idea. I wonder if we could. So the metro is a challenge because like each pin object does take space as well. So we could see if there's no pins connected off the G18, but I suspect that they're all actually used. And so that's what these ignore pins are for, is they allow us to just like not make them available at all. That's one trick. Yeah, so this all takes, like, that's still pretty short. One trick you can play sometimes is you can just look to find new error messages that are like very, very similar and really should be merged. That's one trick you can find. One way that you can free up some space. There's a small chance there's like some... Yeah, there's a small chance there's something that we are including that we shouldn't be. I'm trying to think of what the newest modules are that maybe we have on. The German file did not change. I think the reason that I went over the limit was because I added a property to the e-paper display. So I added the busy pin, which is like it's a function and an object and an entry in a dictionary. Like if we look at e-paper display get, see, so there's a 8-byte get busy object, and then there's a busy object which is 32 bytes. Yeah, like there's this 8 bytes, and then there's this 10, which I guess is 16 bytes. So 16 plus 8 puts us at 24 bytes. And then there's like, maybe it's the first time we use the Q string busy. Carl says, this makes my head hurt. It makes my head hurt too. This is the like what we do to keep things working in CircuitPython category. And like Metro M0 has been out for a long time, so like we can't just turn things off. Potentially the actual best avenue for this is actually to try to get GCC 10 working, which will give us a ton of headroom, which is probably, you know, I could make it squeak in, but maybe because I can see like straight up that it works with GCC 10. Tomas says, maybe just include the most common errors and have an error cheat sheet with codes. Yeah, we're trying to be user friendly here. So we're like, we pay a lot of price in terms of code size and stuff, but it's important to have good error messages. I mean, maybe you can reword them a little bit, but like, wouldn't it be nice to spend time getting like 2,000 bytes free? So we do have an issue around GCC 10, I think. There's this use GCC 10 eventually. And this is one of the reasons we've been able to make it this far, is that like we've had like a number of times where we've managed to Flash Space 17. Yeah. Yeah, that's very user friendly. Right. Gareth says, how long is it possible to squeeze out a few extra bytes? Soon features will have to be frozen so critical bugs can be fixed. Yeah. I mean, that's basically where we are with this AMD, is like we're trying to be as frozen as we can, which is why I'm very much like a stickler for like, oh, you want to add a new feature, you must add it as a separate module, and that module will not be available on this AMD 21 in particular. But we've had kind of a few, like GCC's just gotten better and better. So like we get to this point where it's really hard, like exactly where we are. But like if we go to GCC 10, we're going to get 2000 bytes free. And then the struggle with that is like, you cannot add new modules into those 2000 bytes, which we inevitably do. And, the thing that's probably worth putting in there is the work that Gambler's doing, if I remember right, with a native bus device implementation. Like that's well worth it. It's like a core library that's written in Python, but writing it in C will lead to performance gains, and it will also make frozen stuff better as well. So yeah, let's take a look actually and see if ARM is released. Yes, you made the cut, Gambler. So here's 920Q2 update. And here's a 10 Q2 preview. Moore's law applies to GCC. That's amazing. Not quite, but actually let's see if this like this would be worth trying in the CI. Actually, let's see. This preview was released in June 2020, is not recommended for production use. Okay, so this is what Dan already tried. And I think Jeff actually switched it over. We had some issues. Yeah, so we can see that's what Jeff was using, is that GCC 10 Q2 preview. There was issues with SAMD 51, I think. The USB wasn't behaving. So, yeah, I think the conclusion here is like until GCC 10 is production ready, as released by ARM. Yeah, so like I have GCC 10.2, and 10.2 fixed the SAMD 51 USB issue. And so we're basically sitting around for ARM to release it. Arch Linux releases it themselves, which we could potentially figure out how to do, but we usually use the ARM released versions of the Linux files from them. So hopefully it's gonna be soon. I think they switched to every 6 months they release, so hopefully it won't be too long. Yeah, we can see that like November of last year and December of the year before. So hopefully like November, December, there will be something. That doesn't help me for this Metro M0 thing though. We could take a look at the German. We could try to, The problem is that our error messages are now compressed. So if you think that you're getting 44 bytes back, you might not actually get 44 bytes back. Darn. Nice. Johnny got a white background showing. Drag it over again. Update from Johnny. White background, black text. From Stemma. One thing I also want to try, and we have 14 minutes, so maybe I should just indulge myself. I would love to try Clang. Clang is a compiler based on LLVM. LLVM is a compiler infrastructure project. It's kind of an alternative to GCC. It is more liberally licensed, meaning it is like what, Apache or MIT? What is the license of it? I know for sure that it's does it have its own license? Wikipedia will tell me. So it's a BSD style, or it's an Apache license with LLVM exceptions, which is not great. But the reason this project is exciting is because it's used by a lot of the major tech companies. So like Google has a whole set of people that use it, and like it came out of Apple, I think, originally, or the guy who started it was hired by Apple, so Apple uses it as well. And the reason that you see these big companies using it is because they are a little wary of code that's GPL, because they fear that the GPL will apply to their proprietary code. So by having a more liberally, which is the goal of GPL, right? But by having a more liberally licensed thing where it's like it's okay to mix with other code, means that there's more companies willing to pay people to work on it and kind of just give it out, give their changes kind of like to the commons better. Johnny says LLVM has way better error messages than GCC. Yes, that was, I think, part of their claim to fame originally. But they've actually, like, the competition between LLVM and GCC has really made GCC a whole lot better. It's benefited both projects, I think. Like GCC's error messages have gotten way better from before. And I'd like to try making CircuitPython with it, because not only do they have -OS, but they also have -OZ, which is even smaller. I did try it like a couple of years ago, and it just couldn't produce binaries as small, but that may have changed. Mark says, MD Roberts says, another Mark, what about numbering the error messages and support localization files in CircuitPython directory, since you'll always have a CircuitPython directory? Yeah, I think that's really interesting. I think it's interesting, like, supplementing it. One of the reasons I wouldn't do that is because I want it to just work and always work. So like in the case where you accidentally delete that file from the file system, what happens then? You just get like these terrible error messages. Not convinced that that's the best thing. And we know that we're going to get these 2000 bytes back once we go to the GCC 10.2 or whatever, right? Like we know that. I don't know. It's an interesting idea. Definitely open to ideas on how to get some space back. One thing I actually had, if folks are interested, is that there's actually a lot of exceptions. So every type object is 0.3c bytes, which is what? How many bytes? I don't even know. Can I make a new New tab, please. So 0x3c, 60 bytes. So every time, for every exception, we're paying a cost of 60 bytes. And most of those bytes are actually 0. And so one thing that I was playing around with, and it happens a lot because there's a lot of things of this type. One of the things I was actually playing around with was like splitting that struct into 2 structs where the first struct knows whether the second struct actually is needed or not. And that could potentially be a pretty big win because we have a lot of the same type, especially exception types. So like you can see like all these different types that are all this 03C. And like if we looked at it, what type is it? But yeah, it's like, it's a common thing that we have in memory that like if we could make it smaller, even just by a little bit, we would see that cascade through the fact that it's like used a lot. David, I see your question. I'll talk about it in just a bit. But Keith EE says, could you use a variable encoder to compress that, like a dictionary? So I looked, when I was first running into this problem, I looked at like, is there a best practice for compressing a lot of small strings? Because error messages have this property that they are sparsely used, but they're kind of randomly used. So you can't just like prepend it all or like append it all and then like do like a standard compression thing that makes large files smaller, because like you're actually dealing with a lot of small strings. And so I did a first pass on that with Huffman encoding. So basically like the most popular characters in all of the strings use fewer bits and the least popular characters use more. But I think Jeff did some work originally, and then I think Syscorn did some work, and Jeff worked with them. So we actually do like trigram or n-gram based compression now. So you do compression based on like a number of not Unicode characters, but bytes, which is another thing that maybe we could squeeze out these 44 from. So there were some changes to that as well. I don't know. I'm gonna have to think about this. I'm not sure the right way to go about it is. But yeah, the challenge with compressing error messages is that it's a lot of small stuff. Where would I look in the repo to look into that? Great question. It is in Pi MK stir data, I think. Johnny says just drop German. No? Is it data? So here we get the translations. Adding carriage returns to work in terminals. Compute Huffman coding. So like we do use, yeah, here you go. So yeah, this is the file. So it's in pi/make_qstrdata. Until the dictionary is filled to capacity, use a heuristic to find the best word 2 to 9 grams to add to it. The text splitter allows us to avoid considering parts of the text that are already covered by previously chosen words. For example, if the is in the words, that then not only will the not be considered again, neither will there or whither, since they have the as substrings. So there's this heuristic here. And there's this like arbitrary, like if the word occurs 5 times, then do it. Like maybe if we change this to like 6, it would change it. Should we try that? Let's just see. I'm curious. Okay, so our original was 1984. Let's clean it. Let's edit pi make Qster data, and then I think we can find just under 6. Yep. So what if we just do 6? So who thinks it'll go up? Who thinks it'll go down? If you don't have special characters, you might be able to save some space too. Yeah, I think we're handling Unicode okay at this point. It's interesting because the variety of characters that we support also impacts the bitmaps that we store for the font. So we have a built-in font as well. Oh, look, it's exactly the same. Which gets me into talking about fonts. David had a question. Did we discuss dithering for fonts to use better readability? What if I could write in black and white to a buffer that is 2 times bigger than the real screen, and then display AO squeeze it down to the e-ink and use gray? Yeah. I think that the scaling that TileGrid does right now is not that great. You could definitely support that in like larger builds. Like you could add that functionality without changing the API. I don't know. So like we usually use BDF font format, which is this like ancient binary font format. Glyph bitmap distribution, and I don't think it does. Like it actually uses like hex values to encode stuff, so I don't think it's possible using it to do grayscale. I guess that's what I'm getting towards, is like the bitmap font would have to do grayscale instead of doing like a down sample to get it. I mean, you would have to change TileGrid to basically like TileGrid can only scale up, it can't scale down. So yeah, you would have to add like the ability to set scale to like 0.5. And then you could do the dithering. Yeah, I understand what you're getting at. Fonts are complicated. To do fonts well, I mean, I would talk with Joey again. Joey has done awesome font work with the open book, so I would talk with them. Yeah, I just don't have a good answer about nicer fonts on a grayscale screen. Like most fonts these days are actually like vectors, but then they're vectors where like there's like a logic language that tells you how to like adjust the shapes for where they are on the screen. It's not simple at all. All right, well, I've got to keep thinking about how to save this space. If folks have any ideas, please let me know on the Discord. It is 4 o'clock, so I want to wrap up shortly, but let me just do a little bit of a teaser. So I bought this domain that it doesn't have anything, but I bought this domain called baremetal.ninja, which I was pretty excited to see that it was out. And this is, I think maybe I've talked about this before, but I really would love to replace Make for bare metal projects specifically. And some of you have heard me. I remember Unexpected Maker knows that I've said this, so it can't. I've had to talked about it before. But I would love to make a build system that's geared towards bare metal projects. And it, in my mind, would it make it easier to do like tiny USB, tiny logic friend, and the Raspberry Pi bare metal stuff. It's like I would like to centralize like the standard command line flags for like systems like this. Um, so I've been kind of like pretty distracted by that. But I did some work on it this week. And if you look in, I have a baremetal.ninja branch. It's not ready yet. But I had this crazy idea where my goal is to. So the original way I was thinking it would work, and this is kind of the mental model for CircuitPython right now, is that you say make board equals translation equals, and then like everything that happens after that is to produce just that single kind of variant of CircuitPython. But one thing that makes CircuitPython a challenge and unique is that we have this matrix of builds, right? We have 150 plus boards, and each of those boards has like 11 translations. So we're producing, over 1,000 artifacts for any given version. So I thought, what if I was able to produce... so Ninja is a great resource. I don't know if I've talked about it. Ninja build. So this is like the low-level engine for building stuff that CMake commonly uses, and it's like used by a lot of other tools. And it's like specifically designed where you generate its files, and then it does the like tracking of like dependencies and what order to do things in, that sort of stuff. So where I'm at is that I had this idea where I think I could generate a Ninja thing where if you build like Metro M0 Express on German, like it will build just that and everything it needs, but the dependencies that it has that can be shared will be shared if you drop or if you build another board. So instead of like having to start from scratch and generating new Ninja stuff for a specific board, what it would do is like you'll actually like understand that like at the top level you have this matrix of things. And what I've been working on is figuring out like for any given C file, does it depend on those kind of two main or three main axes of like inputs. And so what you can figure out is that you can figure out whether you can share, like if you can compile a C file once and use it for all Cortex M0 pluses, for example, like that's a win. So that's kind of what I'm going for. So what I've been working on is kind of like starting to figure out like in the end, I would like the dependency tree of the Ninja file to like be smart and know that like this file is board specific, so I need to make 150. Like I have 150 targets for that, but for this like pi_obj string, which is just the string stuff in CircuitPython, like I only need to build it once, and all 150 of those board objects can depend on that one file. So the approach I'm taking right now is basically using Ninja to do somewhat of a MapReduce style thing. Yeah, so Alvaro points out that Ccache might do this by accident. I was talking with Jeff about this earlier, and that was his thinking as well. But my argument was that Ccache is going to cache based on the flags you give it at the start. And there's a lot of flags that we used for customization on a like per board basis. So I'm not convinced that's gonna work. I don't know a lot about Ccache, so it might, but if like right now in CircuitPython, every C file that we build gets past the board name, right? And so like if that's a unique like portion of the key that the cache uses, like you're not gonna get hit at all, basically. And so what I'm working on now is basically like in one sense, writing a MapReduce where like for every file, I filter it down to just the preprocessor macros. And then I basically need to figure out that like this C file does not care what the board is. Or this C file cares what the board is, but there's groups of boards that all share, right? So like all the Cortex M0s can build this file once because they just care about like the compiler flags or something. So that's what I'm working on. I've got it, like I'm treating it like phases. So like the build directory has like phase 1, phase 2, and we'll have a phase 3. I think I need those 3 phases to basically get to the point where I know that I need that like the board causes me to have 150 variants of this file or not, that sort of thing. Well, so David says, so if you split the error messages outside of the compiled code, you can make much less compilation. So we actually do that right now. If you build one translation and then build another translation, unless there's a flag that says like rebuild it all, but like most of them by default shouldn't have to do that. What they'll do is they'll just recompile the object that stores the translations and then link it in again. So you can just the linkers run again by default right now, which is why when you see the CI run, it runs for every board and then does all the translations one after another. Like you have default short error messages and a file drop to have the other languages. Yeah, that's true. I mean, yeah, kind of like what MD Roberts was suggesting earlier is that we could have short default error messages and only translate to the other languages otherwise, with a file present. But still, like I'm so about making it easy for people that like if it doesn't work by default with another language, that's kind of a failure in my book. So I don't know. I don't know what the right thing to do is. Potentially we could like compress the we could like compress the font maybe. Maybe that's something we should look into. Because we do store a bitmap font. But then if we compress it, if we need to use it, then we need that. But yeah, what are the statistics of non-ESUN downloads? I'm sure the US English is by far the biggest one, but that doesn't mean that we shouldn't have the others. This is kind of like also my philosophy is like just because it's not used doesn't mean we shouldn't do it. Like it's the right thing to do. Like if our goal is to make coding accessible to beginners, having it like the text part in their language makes so much sense. But yeah. Make error codes URLs. We do have one URL in an error code right now. You'll get a URL if you do the NPY versions mismatch. We do have a URL for that. But URLs assume that you have internet access, which is not something I would like to do either. Keith EE says, could there be an error-focused dictionary that can be built to encode those specifically and a flag to tell the compression to switch between the standard compressor and the error compressor? I don't think that's going to help you because the vast majority of the strings that are compressing are errors. There's only a few messages that are not errors. One thing we could look at is compressing Q strings. So like all of the, and those will be English. Like those are like your keyword arg names and your function names and your module names. We don't actually compress those right now. So potentially that's, yeah, you could have a translated string dictionary and a native English dictionary, but Q strings get tricky because you can add more of them later. So like when you do an import of an MPY file, like then you have to determine whether you want to store, like compress those on the fly with a dictionary that may be imperfect, or you want to just store them as raw. And if you have both, then you have to make sure that you know which one you've got. Yeah, so Keith, I've piqued your interest. I like this a lot. If you want to just see what the strings are, just go into the locale directory and look at well, all the translations, but the the POT file here is the one that these are the strings that get taken out of the code, and this is what the strings are. Um, so all of these are compressed, and this includes the non-error ones as well. And then the translations live alongside that. So if you want to see like what the Spanish version, like here's one thing that's not an error that says like please file an issue, like one of the safe mode messages. You can see what the translation is. Like one of the ways to fix bugs is like, or one of the ways to get space back is like occasionally you'll find error messages where like most of the message is the same, but there's like one word that's different. You can sometimes like factor it out and put like a C format thing in its place. But yeah. Yeah, so everything like between the quotes on the message string is what we're compressing. But we're compressing them individually. So we have a shared dictionary that you also don't want to be too big. And then you're compressing them each individually. So the way that it works is that after they get compressed, they end up in, oh, I haven't found this file in a while. It might be in supervisor shared translate. So there's this decompress function. No, not that. There's this translate function, and it includes this header that's generated by the thing that compresses it. Yeah, David G says the dictionary is unique to each language. Yes, it is. So the QString stuff runs, and that gathers all the translations as well. They get compressed, and then this is where they end up. They end up in this translate function. And this translate function is called with a const char star that we rely on the linker, the link time optimization to basically remove. So we expect that this translate function doesn't actually occur. We expect that the site that calls it gets replaced with the translated string. So I guess that means that it's possible that those strings could be stored multiple times. So Keith E says, say I want to write my own compressor and decompressor for those strings. How would I compare my compression to the make QString data compression? So I would encourage you to just change make QString. There is a file in gen header. What was it? It's actually just included right here. QStrdefs generated. QStrdefs generated. So this here is, you can see the words that it picked. So here's the 63 words that it picked to compress. And then this is the Huffman table that it ended up with. And you can see the words are entries in the Huffman table as well. So the Huffman tree is 256 entries. And that's kind of fixed. And then, yeah, so the Python code actually just includes debug data about it. So then you can see that these translation entries are the things that are used. So you can see the original English string, the compressed bytes, and then in the comment is the original translated thing. Oh yeah, and then at the bottom it says there's 6,000 bytes worth of QStrings, there's 17,500 bytes worth of translations, but it compressed to almost like just under 9,000 bytes. So that's kind of like the how well is it doing, and that's pretty impressive, I think. Like 50% compression, I think is pretty cool. Okay, I gotta call it. I gotta get out of here. But it's been a pleasure, and I hope that that's piqued your interest and piqued folks' interest. If you have ideas on how we can get some space back, or know anything about TLS, know anything about build systems, if that's your fancy, or just want to hang out and talk CircuitPython, join our Discord. You can go to adafru.it/discord. That will join you on the Adafruit Discord server. I'm Scott. I work on CircuitPython for Adafruit. You want to support me, please support Adafruit. They pay me to work on CircuitPython. They pay me to do the stream. So you can do that by going to adafruit.com and purchasing any of the hardware that you see there. Will benefit Adafruit and will benefit me. So check that out. The mag tag's pretty exciting as well, which is the device I showed earlier. Thank you all so much for hanging out and talking CircuitPython. I love to talk CircuitPython. Join the Discord if that suits your fancy. Remember to like the video, as Alvaro points out, and also a reminder that next week is on Thursday, so 24 hours earlier than normal next week. And with that, thank you all for hanging out, and we'll talk to you next week, or on the Discord before then. I'm not going to pet the cat because I'm getting out of here, but bye.